So I've been working a lot with ChatGPT and Copilot lately, and I kind of wanted to make a video where we don't use AI at all. Because when you use AI, you often end up not thinking about the details, and sometimes that's actually not what you want. You want to know the details, you want to understand the details. So we are not gonna use ChatGPT for this video, and I'm also gonna disable Copilot. So now we don't have Copilot, we don't have ChatGPT, and we're ready to go. What I'm gonna do in this video is look at something called morphological analysis of images, I guess you could say. So also here on Wikipedia, it's called mathematical morphology. And it has a bunch of operations. And basically the idea is that let's take erosion as an example. Erosion will take some object, like for example these black lines, and then it will remove the edges. Then you have another one called dilation, which will expand the edges and so on. And the way it works is it will check every pixel, and so for example here we're checking this red pixel, and there's like some area which here is a circle, but it could be a square, it could be anything. And this circle or square or anything is called the structuring element. So it will look in all the pixels of the structuring element. And for erosion, if all of those pixels are, let's say black, then this pixel will also be black. But if even one of them is white, then it will be white. So then you can imagine how it will remove the edge. So these kind of operations are useful if you're looking for some structures, but there's also a little bit of noise and things like that. Let's see. Yeah, so it has a bunch of uses here, but we're just gonna play with it. Now I already made this function random image using my ppm package that I wrote, which is just for making image files in this ppm format, which is super simple. And if we run this, it will create a random 256 by 256 image, write it to test ppm, and what it's doing is placing a bunch of random circles. So let's try to run that, and then we can look at it, and it looks like this. Let's turn auto zoom on. And I want to also add an extra feature, which is, let's say we want to skip some pixels, and we will skip a pixel if this RNG, now let's see how it works. So this should return a random value supporting the, okay, so if that is less than this, so with a 20% chance, we will skip this pixel. And let's do, how is it? Like that? Or do you do like that? Okay, let's try that one. So now the point is that they have some like noisy structure. This will be maybe help make a bit more sense about what the point of this stuff is. But what we're going to do now is implement a simple erosion, or let's maybe implement this dilation instead. So there's some mathematical definition which you can read up on, but like I said, the basic idea is that in dilation is that we want to expand the white areas. So what it will do is look at each pixel and then look in some neighborhood of that pixel, and if we find another white pixel, then we will make that pixel white. So these pixels in here, they should go away, and the circles in general should be a bit bigger. So let's have a look at doing that. So we're gonna make a function that we call dilation, and it needs to take an image, and that image might as well be this ppm. And let's later add a structuring element, but for now it will just be some default, let's say 3x3 or 5x5 structuring element. It will return a new image. So perhaps here we should say that this is a reference, and let me just build this. So there's some unused code, which is fine. Okay. So let's make a structuring element, and it has to be, I'm not sure how we will represent it. So for now, let's represent it as, so it's basically a matrix. So let's represent it as a vector of vectors, and this particular case is quite simple. So actually I'm not gonna write all that out. So we want to do 5 times, we want to say structuring element, and we just push 5 once. And now just to check, let's see how that one looks. If we run it. So let's now call this one input instead, and then run dilation on it. And here we'll call it output, and it should be a reference, and let's run that. So it will panic, but here you see that we have a vector of 5 vectors. Okay, so now we should apply it, and I want to make a copy of this guy. I think this is not implemented, so let me go and find that. I think it's out and creates and clip. So there's no copy for this guy, and really it shouldn't be copy, it should be called clone, and in that case we can just derive it. Let's complain about this one because color does not implement clone. Nice. And this I we don't really need. Okay, so now we have a clone of this, and then I want to loop over all the pixels. So actually, I guess I would like to do something like this. Would be very nice. Let's loop over the this. So how do you make an iterator in Rust? So basically, I want to do something like. So here we have the ppm implementation. I want to say pixels, which take a reference to self, and it returns like an iterator over colors, right? Because well, it's already okay. So it's a bit redundant. Let's actually make all of these public, and then do like that. And okay, so that's the problem. I want the coordinates. So let's do this instead. This is what I want. We'll go to the implementation. We will go here and we will say public function coordinates. And it should take an iterator over, I guess, use size, like that. Is this valid code is my new question now. Doesn't look like it. So it's replace the generic bound with the associated type item. I'm not sure about the syntax there. Do I say item equals use size? And then because it's dynamic, now I have to box it. Is that it? Oh my god. Go here. This is a bit annoying. Okay, so I was just reading about it and I think I'm not gonna bother with it right now. I'm just gonna say for x in 0 to image dot width, and then for y in 0 dot image dot height, and give me that. Okay, and then what we need to do is to loop over all the neighboring pixels, or rather loop over the components of the structuring element. So there's like an offset, and there is let's call it the weight. Actually, at this point, just to not so it's not weight, it's like should check or something like that. And then we want to, and actually it's a row, and this is actually y. So we're gonna loop over the structuring element. And is there an enumerate? There's an iter, and then is that one has an enumerate. And complaints about that. Where is the missing in? I don't. Okay. I just hadn't saved. And then we want to say for dx and should check. And structuring element, not structuring element, rather row. Iterate that and enumerate that. Let me check that these have the right type. Yes, and this one is a vector of booleans. This is a usize, and this is a boolean. Great. Okay, so let's call it new x. Now there's a whatever. So the new x is x as I32 minus dx as I32, because we want to say subtract. I guess we have to cast, and then we need to check that we are within bounds. So this one should be greater than or equal to 0. It should be less than the width. So it should be an and I don't need that. And if that is also greater than 0 and less than the height, then, and this is dilation, which means that even if there's just one, and so let's say, what do we call this? Actually, we don't need to call it anything. So another thing we can do is, if not should check, then we can just continue. Don't need to check this one. And this it doesn't like because it's an, okay, so we'll just convert it. Great. So if all of that is true, and we know we should check, then let's say if image, and we want to do nx as usize, let's do nx plus ny times image.width as usize. Actually, there should be a method for that. There is not, but we have a get pixel, we have a set pixel, so let's make a get pixel. And we just need a reference, and it can be a U32, and it should return a color. And it's basically this, except that we just return that guy. Okay, and we need to implement copy for color, which is fine. It's like quite low weight. Another thing I then want is to check if, let me see here, just verify how I made it. So it's a white pixel, completely white pixel. So, okay, maybe that doesn't belong in that library, but let's check. Let's make a function that checks whether a color is white. And let me remind myself, what is it's U8. So we want to return color.red equals 255, color.green equals 255. And that should do it. These are private. Okay. So let's say the color is image.getPixel. We have to cast them. Then we have to say if color, if it's white color, then we want to take the output image, set the pixel to this color. Sure, why not? It's white, we know it's white. And once we're done here, we just return the output image. And then let's also write that. And let's see how long the code is. Okay, it just ran. So here we go. That was wrong. We have to always do that. Okay, so kind of strange that it seems like it didn't do anything. Let's try to do a diff of the images. So let's say number of pixels, number of diffs, and we'll make a small function to check, and if images, image 1 is a ppm, image 2 is a ppm, and it'll just return a usize, and I guess we can say if the height is not equal to the height, or the width is not equal to the width, then we just panic. Cannot compare images. Should never happen. Okay, and then we want to say for let's say diff count is 0. And then for x in 0 to image 1.width, and for y in 0 to image 1.height. If, so let's say color 1 is image 1, that get pixel xy, color 2, image 2, get pixel xy. If color 1 is not equal to color 2, then diff count plus equals 1. There we go. Return diff count and try to figure out. Okay. Can we just derive partial eq? Not quit, that was a mistake. Great, so let's try to, how we have it, let's try to print it. Number of differences, number of different pixels. Okay, they're exactly the same, which means that this is never triggered. This one should be triggered many times, so let's bunch of times, and I guess it's never white, even though it's created as white. So I want to check something. Wait, now Copilot is on again, so we have to disable it because I accidentally quit. So, red, green, blue. Yeah, so what exactly? So do we hit this point? Hello? We hit that a bunch of times. And actually, let's call this one, let's call it outer. I guess, is it like that? Yes. Because here then we can actually break outer. like that to make it a little bit faster. Okay, it's very strange. Okay, I also just realized another problem, which is that this dy and dx is going from 0 to some number. It should go from... Also, why is it minus? It should be plus. But then the point is that dx and dy actually need to subtract the size, I think, like that. Let's try to run that. Still there's no difference. And if I make this very large, can I then finally see something? No. Let's just implement debug. I don't want to deal with printing right now. And this set pixel, does it work? Should work. So it is checking different things, which I expected. So why isn't it working? Why isn't it working? Let's say nx is this and y is that, and then x is 32, 32, and copy this, but replace n with nothing. Hold on, it's not nx we're supposed to set. Of course it's x. I knew it was something silly like that. So we're at this point and then we check the neighbors, and yeah, so this should, now there's a, what is 256 squared? Okay. Get me out of this. Okay. Anyway, so input is this, output is that, and now we can see really exaggerated the effects of dilation. You can see even this one was dilated to a huge size. So let's change the structuring element. Let's make it 5. Again. So what will that do down here? It will be 0, -2, and then it will go up to 2. So that's actually correct. And here we go. Has to be an easier way to do this. Yeah, so here we see like all of this noise inside has been removed, but other things have not been removed. Other things have not been added. But the image has been changed in another way. We're not just removing noise, we're also making things larger, which could be what you want. Like maybe you want to make these features more apparent. But it could also not be what you want. So one way to fix that is by first running dilation, where we make things bigger, and then run erosion, where we make things smaller. Because what will happen is that we fill in these holes, and then we make the hole shape, so we get something like this, and then we make it smaller again. Then we should hopefully get back to what we had before. But with the internal holes filled in. And actually that operation is called something. It's called the closing. Closing is dilation and then erosion. Yeah. So let's... this is not needed. Okay, so let's implement erosion with the same what is it called, signature. So now we need to say all present is true, because here we just, if there was just one white color, then we said it was sufficient. But now we need to check all of them. They all have to be white. So we'll loop over all the neighbors. We will then do this bounds checking, and then we'll check if it's not white, then we'll say that there was one that wasn't white, and then we can break out. And then here we can say if they were all white. I'll do that later. So all present And if they are, we do that. And the color is now color new, a fully white color. So let's, first of all, let me try to rename this. And then down here, let me rename that one to dilated. Let me make one that's called eroded. So let's also run that on the image. And we'll write here eroded. And this one we can call dilated. And we'll make a new one that we call closed. So that's just the erosion on the dilated one. We don't need this one anymore. Diff images, I'm just gonna say allow dead code. Let's run that. That was fast. So let's have a look at these different images. There's the input, there's the dilated one, which you already saw. There's the eroded one, and there's the closed one. So let's get them all up here. Input, dilated, eroded, closed. And it's a bit annoying that this auto zoom is not set. This one we already saw, the holes are closed, and the what are they called? The blobs are also a little bit bigger. Now let's have a look at the eroded one. I can already see there's some kind of problem. The eroded one didn't really erode anything, like for example this one. These should probably not be there. And like it seems like there's no change at all. Let me quickly make a script that's just called open, and it will open the input, it will open the dilated, it will open the eroded, it will open the closed. Okay, let's close these again. So what went wrong now? So it is triggered a bunch of times, and let's say else if is white image dot get pixel, like so. So some it's because we okay, so the problem is that if they're all white, then it should be white, otherwise we have to set it to black. Now, run it. Let's open them all. Okay, this looks a lot more correct. So, as you can see, the eroded one has removed a lot of stuff. Almost everything, in fact. Basically because they have these holes. But if we run first dilation and then erosion, which is this one, closed. So closing, which is the closing operation, this morphological analysis. Then we can see we have just ended up removing all the inside holes, which I think is quite nice. If you want to, if you consider like these small blobs as noise, then you could perhaps run another erosion on this, perhaps an erosion and then a dilation, which should remove these small blobs. And you can also change the kernel size and things like that. So there we have it, a little bit of morphological analysis. I kind of want to have a trait that's called a structuring element, and it should have a function that is called let's call it elements, or like get elements, which takes a reference to self and returns basically I want an iterator here. Maybe we don't do that. Maybe we just return a vector of, let's say I32, and Boolean. It's not like that. You don't do that. And it doesn't need to be public, probably. And I didn't spell it right. But then this image could take a structuring element. And again, I didn't spell it right. Okay, so I just looked it up, but evidently it's like this. You write it. It's something that implements structuring element, and then I want to do this, and then basically I guess the idea would then be that we say structuring element is the structuring element that get elements, which will construct this vector. So we just like do this construction, and then we use it. And then we also need, and then we shouldn't need this anymore. And there is also no need for this. We basically want to say dx, dy should check in structuring element dot, and we just iterate over that. those can go away. One of these is not necessary. And here we break. So let's try that. And we don't need to enumerate it. And here is some kind of cast. It's a bit weird. Can I do that? Why to owned? Still doesn't like that. Still thinks it's a reference. Okay. So that's how we want to use it, and let's make something that we just call a square, and it should have just a vector of vectors of booleans, I suppose. And then we can implement the square. There can be a new function which takes a size, and we want to say make some rows, and for each row make a row. For each of those we'll say push through. And once we've done that, we can return self with the rows. It's a bit verbose. And this one what do we call that? We call that, I don't want to call that anything. I just do like that. And then the syntax here is that we do this. And we have to return it. And then we want to say implement structuring element for square. And we need to implement get elements. Okay. So that's the size, and then we want to say for dx, rather dy row in self iter for dx, and then boolean in self in row dot iter. We can just there is a functional way to do this. I'm just going to do it in this way. Anyway, so here we want to push dy as I32 minus size as I32 divided by 2. Actually, just x, and dy as I32, size as I32, and finally b. Right, and this one has to be enumerated. Right, we have to return it then. That was the problem. Okay. So now down here, when we're doing dilation, we can say let the structuring element be a new square of size 5. And we return a reference to that. It doesn't need to be consumed. Then when we run it, there is a huge problem. Let me. What's the? Right, because here we have to say rows that push row. Okay, so you cannot do that. And then we have to dereference it here. That's amazing. Now it ran, let's open it, check it's the same. It looks more or less the same. Of course, the image itself, like the location of the spots are different because the image is randomly generated each time. But it looks like it's functioning the same way. So of course you should do the same refactoring of the other functions, but I think that's it for this time. See you in the next one.